So in this section, section 12 of chapter 4, we'll learn about non-equilibrium application of Newton's laws of motion. So in the last, or 2 sections ago, I think, we learned about equilibrium forces. So that just means that they're either at rest or at a constant velocity. And because of this, they are in equilibrium. So if we have a box being pulled, then their tension has to equal to their Fg if it is in equilibrium. And equilibrium, again, just means at rest or at constant velocity. So this just means that the net force is also equal to 0. Now, in non-equilibrium, which is what we're going to learn right now, just means that there is acceleration happening in that object. So in order to find the force, you just need to find the x and y components and then put them together to find the magnitude, and then you can find unit force. Okay, so here we have our first problem, which states a truck is hauling a trailer along a level road. As the figure illustrates, the mass of the truck is 8,500 kilograms and the trailer is 27,000 kilograms. The two move along the x-axis at an acceleration of 0.78 meters per second squared. Ignoring the forces of friction and air resistance, determine the tension of the drawbar and the force of D that propels the truck forward. So first we'll draw the forces being acted on these objects, and notice that we have to find the tension of the drawbar. So we know the masses of each and the acceleration, so that kind of brings you to think of the force equals mass times acceleration equation, but no, this is on the x-axis, and know it that because it's talking about the drawbar, then the mass has to be the mass of the trailer, so mass 2. So doing this, you get an acceleration, the force of 2,100 newtons. And now in part B, it asks you the force of D that propels the truck forward. We know that D is all the way over here in green, and it's pulling the entire truck plus the trailer that is connected with the drawbar. So D is all of the forces added together. So in this case, it's the mass of the truck and the acceleration of the truck plus the force of the trailer, which we already calculated in part A. And that added together will give you the force of D, which is 28,000. Okay, so in this second question, we have a window washer on a scaffold is hoisting the scaffold up the side of the building by pulling downward on a rope, as the figure shows. The magnitude of the pulling force is 540 newtons, and the combined mass of the worker and the scaffold is 155 kilograms. That we're gonna have to change it into newtons later on. So find the upward acceleration of the unit. So first, let's draw the free body diagram. So we have 3 tensions pulling upward with the same force, and we have the weight is equal to the mg. And we know that their mass is 155 kilograms, so we can figure that out. Now we know that the force is equal to the mass times acceleration, where the force is the addition of all forces as well. So if we do those two equations, mass times acceleration equals the forces all added together, we know the mass, we know the tensions, and we know the weight, and we just need to find acceleration. So through this equation, we can find acceleration, and acceleration will end up being 0.65 meters per second squared, pointing upward. Okay, so in the third problem, it states a 1,550 kilogram submarine rises straight upward toward the first surface. Seawater exerts both an upward buoyant force of 16,140 newtons on the submarine and a downward force of 1,030 newtons. What is the submarine's acceleration? So again, we kind of have to use the same thing, force equals mass times acceleration. So we have this submarine with a force going upward and a force going downward, and we are also giving its mass. So remember that force equals m times acceleration, and it's also the addition of all forces, so P plus T. So if we do this equation once again, we can figure out the acceleration of the submarine, which is 10.42 meters per second, going upward or positive because there is more force pushing the submarine upward than pushing the submarine downward. And we're kind of told that in the question as well. Next, we have a 15-gram bullet is fired from a rifle. It takes 2.50 times 10 to the negative 3 seconds for the bullet to travel the length of the barrel, and it exits the barrel with a speed of 715 meters per second. Assuming the acceleration of the bullet is constant, find the average net force exerted on the bullet. So here I drew not a rifle, but a gun, and the bullet shooting from it, and we see that we know its mass and we know its time, and they also give us their speed. So somewhere in here we're gonna have to use the acceleration, and we use it because they ask us for our net force, and we do have our mass, we just need that acceleration. So we just do the velocity over the time, and that gives you the acceleration of, you see, it gives you acceleration of 286,000 meters per second squared, and multiply that by 0.015 kilograms, and that will then give you the net force, which is around 4,290 newtons.